Hello, welcome to the Scientific Visualization course. My name is Alex Razumov, and I'm a Visualization and Training Coordinator with WestGrid. For this course, you'll need ParaView installed on your laptop. If you haven't done so, please go to this website, www.paraview.org/download, and download a precompiled version of ParaView for your operating system. It is available for Windows, Mac, and Linux. You also need a copy of the slides, sample datasets, and codes, and these you can find in a zip file at bit.ly/ParaViewZip. Open this link in your web browser, and it will download a zip file, unpack it, and put it somewhere where you can access these files. In this course, I'm going to teach you how to do three-dimensional and two-dimensional visualization with ParaView. We're going to start with a general overview of various scientific visualization tools. I'll talk about various Python packages, about one-dimensional and two-dimensional plotting versus multidimensional visualization. I'll talk about Plotly Python package in a little bit more detail, and then we'll jump into ParaView. We'll take a look at its architecture, how to start ParaView, how to import data into ParaView. We'll talk in depth about VTK file format and various types of discretizations you can use in VTK. Then we'll jump to basic workflows, creating a pipeline using filters, and so on. And then we'll go to more advanced topics, scripting, how you can script your entire visualization using ParaView Python, how you can create animations inside ParaView, and then I'm going to give you a couple of demos of remote visualization on Cedar Cluster. Throughout the slides, you will see some more advanced topics, and some of these I will cover briefly. Some of these you can study on your own. So I think most people already have a pretty good idea of what scientific visualization is. So essentially, it's the process of mapping your scientific data, digital data, to a visual form. For example, if you're running large-scale simulations and you have gigabytes and gigabytes of data, of course, it's impossible just to look at these numbers. So you have to convert them into a visual form. And for that, you'll use special visualization tools, libraries. And I can give you many examples from different fields. For example, if you're running a computational fluid dynamics simulation, typically you deal with two-dimensional or more likely three-dimensional distribution of various fluid properties like temperature, density, velocity, various tracer fields, etc. And you want to visualize this. Perhaps these three-dimensional distributions are defined on a Cartesian mesh, perhaps they define on a curvilinear mesh, or on some sort of an unstructured mesh, or perhaps there's no mesh at all, just a bunch of moving particles. If you're working in climate, in weather modeling, then typically you're also running fluid dynamic simulations, and you need to visualize three-dimensional distribution of quantities. My own background is computational astrophysics, and there people run all sorts of numerical simulations, from stellar hydrodynamics to planetary atmospheres, to galaxy formation, to jets, accretion disks, interstellar medium. And typically, these are also fluid dynamic simulations. Or perhaps you have particle data, perhaps you're running an n-body simulation, and you need to visualize a distribution of point masses. Perhaps you also have gravitational fields, magnetic fields, radiation fields, and you want to visualize this. If you're working in quantum chemistry, then you're solving the Schrödinger's equation, and its solution is the wave function or the probability density distribution in 3D, and you want to visualize it. A very popular numerical field is molecular dynamics. Here you typically have a bunch of atoms, and then these form molecules, so you want to visualize atoms and links between them. Perhaps you want to visualize proteins, various biological molecules. And you can do this with general purpose tools, but there are also custom tools specifically designed for molecular visualizations, things like a Visual Molecular Dynamics package, VMD. So in this list, bioinformatics and humanities are kind of separate from the rest of the fields because they usually have very custom and very specific datasets that are different from typical numerical datasets from other fields. So in bioinformatics, people usually use very custom tools, and there are dozens and dozens of tools for visualization in bioinformatics. But these are usually tied to the bioinformatics workflows. So it's very difficult to use a general purpose tools for the bioinformatics datasets. And the same applies to humanities. So in humanities, typically you have very unstructured data, perhaps some linked data sets, graphs, and you would often use very specialized tools for displaying these. I also want to mention that in Compute Canada, we have a national visualization team of high-performance computing experts who are interested in visualization, and they provide visualization support across the country. So the website bit.ly/cctopthis. If you go there, you will see the types of visualizations that we create for researchers, and you can click on any thumbnail in the gallery, and that will give you a much bigger visualization. So these are the types of visualizations we create with general purpose three-dimensional tools. Also want to mention that every fall in WestGrid and in Compute Canada, we host a Visualize This competition, which is open to all researchers, students, postdocs, anybody from Canadian universities. And typically we provide a data set, and then we ask you to submit your visualization. So you have 2 months to do this. So keep an eye on this website, and we'll have an interesting data set this fall.